Over to you, Ajit and Vibin.
So a quick summary again about me. I think the key points I want to highlight is that I have both had a core engineering from a material science perspective background and also a software background. So it should be interesting for people today because they do see a lot of trends that are from the world of software disrupting the normal core engineering work. I've done pretty crazy stuff. So traditional engineers would just do a process and lithography or process work. I did a couple of math work, couple of interesting things, which might be interesting for a lot of folks. The key point I want to make for everyone is career is what you want to make it out to be. So if you look at my career, that's pretty much where it has gone. Okay. So moving on. The topic was opportunities in emerging technologies. So I just want to give a quick summary of what's happening, at least what people should be seeing of late. There might be 100 different other things that of course pop up relevant to people's field of study. Chemical engineers, civil engineers might see very different things that are on top. But these are some of the common things that seems to be like ramrodded down everyone's throat these days, right? Everyone is talking about AI, everyone is talking about big data, cloud computing, and a bunch of other things, AI, VR, 3D printing. It just goes on and on. Name it, you would find one of those things over here. So hearing all these technologies, the key thing, I guess, for a student's perspective is, why should I care, right? You're going to be thinking about in two perspectives, right? There's going to be related to existing roles. You're going to think, hey, what's going to happen to my existing roles? Are there going to be enough jobs out there in the market? Is the world of engineering going to be redundant, or is it going to be absolutely disrupted? That's always a question. So it has been the same since, I don't know, time immemorial. Since the advent of technology, people are always worried whether their livelihood is going to be like out and they're going to be out in the streets. And it's going to happen again. So that question is always going to remain. But I'm going to give some general thoughts or suggestions, and then we can carry it forward from there. There are also a bunch of students who would be interested in these technologies. These are just not keywords to them, right? They're going to be interested in, say, applications of ML or applications of, let's say, nanotechnology, and they're wondering how does a career that they've been trained for by universities, which are pretty much 10 to 15 years behind on the curve in terms of technology, gonna impact how they're gonna be ready for the job market and how they're gonna make a fit, or what should be they doing, what should be the opportunity they should be looking for, right? So you're gonna think about that, and then you're gonna think about like, how does it affect me, right? Like, how does it affect what should I do? I think these are the key two things every student must be thinking. If you're not thinking on it, you should start thinking on those lines. Okay. So let's take the first thing first. So going to the point of how will it impact me? I guess the key thing to understand is if you're an engineer, the world of engineering is pretty like stable. The technologies don't come just thrown from a lab to the real world. There's a maturity curve. It takes time to get out there. And also the fundamentals of engineering are pretty much like bolted down and secure. So if you look down, this is the case 100 years in the past. This will be the case 100 years into the future. It is the case today, of course, where most of the jobs are they're going to be stable. They're going to be related to your core field. So if you are an engineer, you're graduating, it's going to be it's a process engineer, a device engineer, maybe an R&D engineer, but it's going to be related to your core field. So if you're a material science engineer, you have done work in semiconductors, you better have your fundamentals of semiconductor industry really really solid, right? So whether it be photolithography process, it's gonna be vapor deposition process, or physical deposition process, or like etching, whatever it is, it better be solid over there. You understand the process. You better have experience related to what you have done, so you can actually go ahead capitalize on it in industry. But the industry is going to function pretty much the same way. For most engineers, the job is not going to change. Even R&D engineers are going to worry about how do I bring in new materials. The process is laid out. It's a very standard process, and it is well vetted, and you'll go through the same process. So those kind of processes will continue. So first, the key thing to think about in your mind is 90% of jobs out there, even if it is for a software engineer is going to be doing jobs related to client servers. So whether it is a client side, server side, that's largely how information is presented today. You would work on those. So fundamentals of industry are exactly as it is, and you would need to go there with that same set of capabilities and awareness. So 90% of your jobs are going to be that's going to be the same, right? There's going to be a few changes, and in fact, those few changes, companies themselves will train you for it, or you can pick up stuff. So as long as you have ability to learn, you keep yourself flexible, you can get those things. So think in those lines that, hey, is your job uncertain? There may be downturns. Everybody goes through downturns. Market may not be taking in students at this point of time, but don't worry too much about like, hey, is a job X going to remain? A civil engineer job is going to remain. You better be comfortable with your fundamentals. And if that is a direction, it's going to be a fantastic career for you. Okay? But where does the change happens? So with new technologies, there are going to be new job roles that open up in R&D. Okay, we'll go through a few of what that means. So when technology innovation happens in one field, the impact of it is felt in across all fields. So you would see new ways of doing things. You'll have new opportunities to do research. And if you're a kind of person who likes to be in the cutting edge of work, if you call it the cutting edge, you will always find opportunities in that direction. So there will be new jobs created. There'll be exciting jobs, and we'll go through quickly a few of them. And of course, we can take up more as we discuss. Also, there is going to be jobs at the intersectionality of different subjects. So if you are a person who's just done chemical engineering, should you pick up computer science related knowledge? And how do you merge them both? If you're from pharmaceutical industry and computer science industry, how do you merge both? What are some of the opportunities? That'll come up too, right? Or it could be like materials and civil, right? It could be an intersection of a lot of these things. So again, they are going to be exclusive. They're going to be limited set. They're not going to be like be hired on the scale. So if you're a kind of student looking for those opportunities, understand those opportunities exist, but they'll not be mass publicized or made aware. You'll have to go searching for it, but they do exist, and they'll be exciting. Okay, this is impact of. Let's talk about the R&D work first. So normally, material science deals with things like electronic properties, physical properties. You'd go deep into it. You'd study the materials perspective. And there are a lot of different things that we traditionally do. For example, simulation is something that most material scientists do. It's also the common case when you look at, for say, mechanical engineers or aerospace engineers, where they do a lot of their engineering work based upon simulating how the responses would be. You'd solve a bunch of differential equations, and then you try to simulate how the things would look like. Of late, there has been a disruption with, for example, ML. ML is, it's great. Normally, you wouldn't expect ML to hit the realm of material science. At least I wouldn't initially, but things have changed. So, for example, there is an ANSYS report. If you read a little bit into it, ANSYS is pivoting towards like getting more ML to actually substitute their or complement their simulation work, and it is faster. So, if you talk about simulation that runs in like order of days to actually simulate certain components, you could actually get that over like 20x or 30x faster. So that's exactly the finding with ANSYS. I have a quick video of actually a simulation versus a ML neural network model, and you can actually see they're pretty darn close. Like even at slow motion, you can see it's pretty darn close. So the way these technologies work are very different. One solves, under the hood, both of them solve differential equations. One of them looks at solving it for each step, iterating it, and try to find out what a change would be over a period of time. Versus one looks at data and sees how these boundaries get drawn, and then try to predict how a flow would behave on new scenarios. Again, just based upon data that is collected, images that is collected, videos that is collected. Very different approaches. Interesting that the end results would be pretty similar. And in fact, that changes a lot. So if you are in industry and if you want to quickly prototype, would you wait for 20 hours? It depends. It depends on the kind of use case you have. But if you can get something that is order of minutes, of course, it is important to you to recognize that. I have a student who we mentored as part of Careerbolt. He's also from IIT Madras, who actually is working right now in the Berkeley labs, working on exactly these kind of problems. So that is applying ML to material science problems. And the people who would hire him would be people like ANSYS or others. So these kind of research are like cutting edge today, and people are working on it at this point of time. I want to just bring up another case about intersectionality. So when I was working with AWS, which is again totally related to cloud computing, and you would not think how that impacts real businesses out there, not purely from computing sense, but also from how they operate. So this is an example from ExxonMobil. And you can think of the use case like ExxonMobil has those remote oil fields out there that are maybe offshore or they are in remote locations. They're really hard to man. And getting people out there to actually go monitor and fix something takes a lot of effort and a lot of time, right? Sometimes it's not even possible if there are storms and other things out there. So how do you go build a digital twin? Is something like creating a replica of that environment in your lab. So you can see all the data that comes out streams to your lab, where you can actually start visualizing how, for example, a pump is functioning out there, how a tube is delivering certain flow rates out there in the field. And if there is a certain issue, you can worry about, hey, can you go lock it down locally, or do you need to actually send an expert over there to fix certain things? Earlier, the visibility was totally not there. Of course, it comes in layers. You could think of it like, hey, data collection, visibility, and then going ahead and doing some remediation fix. But through the journey, the question remains, how do I get information out there and present it meaningfully for people? And the digital twin is creating a replica of that production environment out there in the field, in the lab environment, such that people can access it, right? How does this impact? So if you are, say, a mechanical engineer, or if you are a material science engineer, you would go ahead and worry about what kind of data are these that you should actually go model in the lab. And you'll also worry about what this modeling means for things like prediction of tool failures and many other things out there in the field. So if you're a mechanical engineer, if you're a material science engineer or chemical engineer, you would need to be involved in such projects. You would need to have a solid understanding, one, of your basics, which is related to your field, pumps, motors, or if you're a chemical engineer, related to flow rates, related to like how reactions happen, and then connect this to the data that is generated. So what is the frequency you collect data? Where do you store the data? How is it secure? What do you need to build there? If you're an electrical engineer, you would worry about things like how does the installation not get hacked? So what kind of security you would build on top of it, right? So it's an entire project that brings in tons of different people with very different skills to actually go ahead and create something that important for the company. So this is again intersectionality, real world project that people like AWS, Microsoft, of course, should be doing the similar stuff, Google too, to actually go make these things happen out there in the market, where they disrupt what is traditionally considered as a very engineering role. Okay, now that comes to the final part of this story. We will get any use case, more things that you guys want to discuss, we'll jump into it. From your perspective, if you know these changes, what should you do, right? For existing jobs, I always say the same thing: be ready with your core subjects, revise, be aware, look at the trends. For example, there's a lot of investment into semiconductor from India. You should be thinking about that if you're 4 or 5 years in the pipeline for graduation. What does that mean for you as a as a material science engineer or a semiconductor engineer? Be also like job ready, right? So being aware of your subject matter is great, but getting a job is a very different thing. So be aware of how do you prepare, how do you interview, how do you present yourself, how do you get the jobs that you're really interested in, those kind of things. What does that mean for you as a career, right? So be aware of the process and be prepared for it. Be doing that work earlier is better. If you're into that R&D kind of work or looking at the intersectionality of kind of work, you'd of course need to be an expert in it. Nobody wants to hire and then teach people what to do. You better have shown interest, have publications like what Ajit has. He has 50 odd publications. Yeah. You better have a fraction of it out there so that you can actually go demonstrate your value in the market, right? Work with your faculty, do some research, do project work. I have a student who's actually from one of the mentees, right? She actually is in electronics engineering from IIT at Harvard, and she's actually getting into ML in allied spaces. She started working on it 6 months ahead, and then she has had a lot of success in terms of projects she want to work with faculty. So again, make your moves 6 months and a year ahead. Be aware of what is happening in the space and go ahead, get it real world experiences. Only then can you actually be ready for the market, right? Actively reach out. Jobs are not going to come land in your lap. So one of my close friends, he works at IBM Research. He works in now designing materials for quantum computers. It's really a crazy field where like even you don't know what kind of logic gates should fit for a quantum computing device. What does that mean, right? So he's thinking through the same problems with a group of people who too are thinking through the same things. These jobs don't come to you and hire you. If you have enough skills, if you do the reach out and if you find the right people, they actually like say, hey, why don't you come and work kind of thing. So do the reactive reach out, things are not going to fall into your lap. So there's a famous Sanskrit shloka, if anybody can read it, it should be pretty obvious to you, but it is that if you're a hungry, sleeping lion, food does not directly enter your mouth, right? You have to go and do the hunt. So it's the same case, things don't fall in your lap, go do that stuff out there, okay? I'll wind my talk for now and hand it out to the illustrious Ajit.